Hey, what's up people? Welcome back to LeoNative. Today we are going to learn how to integrate augmented reality in our React Native projects. For this video, I have a blank project already configured with Expo because we are going to focus directly on the augmented reality implementation. If you don't know how to create and configure a project from scratch with Expo, don't worry. I leave a link in the description where it's explain step by step how to do it. Alright, and now when we talk about integrating augmented reality in a mobile app, there are different options. Native implementation using OrCid for iPhones or OrCore for Android. Third-party libraries, hybrid solution that make things easier. In this case, we are going to use a library that I think is a very good option, mainly because it is not hard to configure, it has a very clear API, and most important, it supports Expo. So, we go to the browser and search for ViroReact. Here we can see the official documentation where we find examples of augmented reality, virtual reality, 3D model rendering, environment interactions. ViroReact let us work with AR using components very similar to the ones we already know in React Native, which makes the learning process much easier. Let's integrate it. First, inside our project, we run the following command to install the required dependencies. We open a new terminal and pass the command. Before we continue, I leave a link in the description so you can download the assets that we will use in this project. When you download them, you will find the following files: logo, which is the image that the camera will detect; garage, which we will use for environment lighting; objectcar.mtl, which contains the model materials; objectcar.obj, which is the 3D model of the car; and then the colors-based image in PNG format. So we move this world folder into the assets folder of our projects. Now we are going to import the materials we need, and we do this using Viro materials. Always make sure it is imported from react-viro. First, we create the white material as an object. Inside it, we add the following properties: lighting model, PBR to make the rendering more realistic, diffuse texture, which will be the base texture of the car, metalness texture, and rawness texture of the assets. Now we copy the same configuration for the blue color, and we only change the diffuse texture with the correct image. Next, we create the materials for the spheres. We start with the white spheres. In this case, we use diffuse color because we don't have a texture for the sphere. We do exactly the same for the blue sphere. And now we need to detect the logo, and we do this using Viro or tracking target. Here we declare our target called logo, and we set the following properties. Source, which is the path to the logo image. Orientation, set of up. Physical width, which is a reference or value of the real image width in mirrors. Now we create an animation so that spheres can go up and down. For this we use Viro animation. First, we create scale up, where we define the scale properties, duration, and then animation type. And then we create scale down, which is almost the same, but we change the scale values to get the opposite effect. Now let's build our scene and add all the elements we created. For the car texture, we use a state with an initial value of white. We also need state to control the visibility of the spheres. A state to control when the animation is running. We create a function to show or hide the color buttons. Here we can use a simple condition to set the correct animation and set the animation state to true. Then we need another function to stop the button animations. And now we create the functions to change the car texture. One for white, and one for blue. We return a Viro or scene. And inside it we add the following. First, an HDR lighting environment using Viro lighting environment. Where we set our HDR asset in the source. Then we use ViroR image marker, which allows us to draw the car when the image is detected. The main property here is target, which we already defined before. Inside it, we add a Viro node, which is basically an empty 3D container. Its properties are scale, starting at 0, transfer behaviors, billboard Y, so the element stay aligned on the vertical axis. Animation, using our states and the function to stop the animation. Now we create the spheres using ViroSpheres. We start with the white spheres. Properties. Materials, using the created material. Height segment count and width segment count for better resolutions. Radius, positioned where X is different for each sphere. Y is 25 and Z is 0. On click, using the function to select the white colored. Shadow casting with mask to apply shadows. Okay, then we copy the same setup for the blue spheres, changing the materials, the X positioned, and one-click functions to select the blue color. We draw the 3D car using Viro 3D object. We configure properties scale with an initial value, source, pointing to the OBJ file, resource, with the MTL file, type OBJ, same source, materials, using the texture state, on click to show or hide the buttons. We create a car animation called scale card, where we set the scale to 0.09. Define the duration and use an effect similar to scale up. We async this animation with run through. Finally, we render everything on the screen. In the return, the view has a dark background. In the status bar, import Expo status bar. Okay, it's light. We use ViroReact navigator. With properties, autofocus true, initial is seen, pointing to our or is seen. Style flex 1. Okay, to run the project, we need some final setup. In app.json, inside the Expo object, we copy this code. Don't worry, I also leave it in the description. This code is basically an application ID. We also need to ask the user for camera permissions. At the bottom, inside plugins, there is something very important. We must add react-viro. This is part of the required configuration for the library to work correctly. Now in Metro config.js, we need to modify methods to support new assets types. First, we change the constant from const to let. We do not export it yet. Here we add support for HDR, OBJ, and MTL files. By default, Metro supports assets like image or audio files such as PNG, JPG, or MP3. But in this project, we are using AR assets like OBJ and MTL, so we need to add this support manually. We add these new formats to AssetsX, and only after that we export the configurations. We can build this project. We run expo per build. This command creates the Android and iOS folders. On Windows, only Android. Then we run run Android device. The device option lets us see the physical device and emulator configured on our computer. It is very important to run this project on a real device because augmented reality doesn't work correctly on the emulator. As you can see, everything built correctly. And now we can see the final result directly in our mobile phones.